All right, so now we're going to jump in and do part D. And part D looks like this. I had the differential equation from before, so I have mg sine theta minus kv equals m dv dt. Now I've got a little bit of algebra to do here, so I'm going to go ahead and get started on that. So I will actually end up getting m dv over mg sine theta minus kv equals dt. And I'm going to do a u substitution here. I'm going to say that u equals mg sine theta minus kv, and du equals negative k dv. So in other words, negative du over k equals dv. And this is what I'm going to substitute back into my formula. So I will end up getting then m du, negative mdu over k, u, equals dt. And so I will end up getting du over u equals negative k over m dt. I'll integrate both sides, and I'm going to get the natural log of u equals negative k over mt plus c. And so I get u equals a e to the negative kt over m. And I'm going to go ahead and simplify, and I know that at, I'll just do a back substitution here, so mg sine theta minus kv equals a e to the negative kt over m. Now I know that at t equals 0, v equals 0. So I'm going to do that to substitute back and solve for a, and when I do and I get my answer, I'm going to get that v of t equals mg sine theta over k times 1 minus e to the negative kt over m. So I did skip quite a few steps, and I think it's because we've just done this problem a lot, so I'm hoping it's a little bit more familiar. Finally, moving on to part E, we want a graph of acceleration as a function of time. So our acceleration is going to be, again, g sine theta minus k over mv. That's going to be what our acceleration looks like. So what that means is that at t equals 0, v is 0, so I have g sine theta as my acceleration here, and then it's just going to die off exponentially as a function of time. So that pretty much rules that out. I think when I actually put in the value for v, I'll end up getting something like g sine theta, like 1 minus e to the negative k t over m ends up being my acceleration. And so this is an exponentially dying off function.